Okay, so we're looking at the next part, which is integrating of trig functions. So we've just done exponential functions, and now we're moving on to trigs. So just to remind you what we're doing, so I get a pen. Okay, so if we've got y, we can get y dash. So sine turns into cos, cos to minus sine, and tan to sec. So if we're going that way, we're deriving, and if we're going backwards, we're integrating. Okay, so if you're integrating cos, you get sine. If you're integrating sine, you must have minus cos, and if you're integrating sec squared, you have tan. Now they're the easy ones, but normally we have functions. Okay, so that means you put the derivative out the front, and then you just change them as you have in the past. Okay, so copy that if you need to, but otherwise let's move on. So let's have a look at a function, y equals sine 3x. So when you derive, the derivative of the 3x, which is 3, comes out the front, and then sine turns into cos. Now what that means is, that should be y dash, sorry. So what it means is, okay, that's deriving. And if I want to go backwards, then 3 cos 3x, if I'm integrating, must have been sine 3x plus a constant. Like another example, if I've got cos 2x minus 3, the derivative of the bracket is 2. Cos turns into minus sine, and then you just leave the bracket as it is. So that means if I've got that minus 2 sine 2x, if I've got that and I'm integrating, it must have come from cos 2x minus pi on 6 plus c. So let's have a look at another example. Can I copy that if you need to? Okay, so what we've got here is some examples. So we're just going to integrate. So what you do is you look at the function is 2x, and the derivative is 2. Okay, so there's no 2 there. Now, I'll actually show you the green way. That might be a bit better. So then I'll come back to this one. So the integral of sine 2x, there is no 2 there, so I can just put a 2 there, but I've got to compensate by putting a half out the front, because the half of 2 is 1. Okay, so whatever you need, so this green method is whatever you need, you put out the front, and if you've introduced a number that's not there, then you put it as a fraction outside the integral. Okay. Now, in actual fact, we need to have a minus 2. So if I put a minus 2 there, then I have minus a half. Okay, and then that number out the front is in front of cos 2x. So I'll just show you the other way I'm doing it. So sine turned into minus cos. 2x stays as 2x, and then you just divide by the derivative. Okay. In this second example, which I think I'll actually do, I think it's on the next page. Yes, I'm gonna rub that out there. We'll do it on the next page. It's a clean one. Okay, and we're going to get some chance to practice those straightforward ones. Okay, copy that if you need to. So again, what we do is we look at that bracket, and the derivative is 2x. Okay, now x is a multiple of 2x, which means I have a multiple of the derivative in front. So once you can do that, you just write what's in the integral, and then you divide by the derivative, and then the x's cancel out, and so you've got a half of sine x squared plus 3. Now this only works if that's a multiple of the derivative. Okay, it can be a whole number, it could be a fraction, so it's whatever. But if this had been, if we had x cos x cubed minus 1, the derivative is 3x squared, and I've got no x squareds, so it cannot be solved in this level of mathematics. Okay, so I think next one's some examples for you to practice. So yeah, so these are straightforward ones. They're not complicated. So can you have a go? What I often do at the start of a stressful situation, I go sine turns into cos, cos turns into minus sine, tan turns into sec squared, and I'll just put that at the top of my page to remind me, if sine goes to cos, then cos goes to sine. If cos goes to minus sine, then sine goes to minus cos, and if I've got tan goes to sec squared, then sec squared goes to tan. So I write that down at the top just to remind me what I'm looking for. Okay, so have a go at those two and see how you go. Okay, so maybe you're back. Okay, so I've got sine, so I must have minus cos, so I'm going to put minus 5 cos 3x. Okay, so sine goes to minus cos, and then you just write that down, and then you just divide by the derivative, and you put plus c, and that's the end of the question. So you got minus 5/3 cos 3x plus c. In this next one, I've got cos, so I must go back to sine. So I just write down 4 sine bracket pi on 6 minus 2x, and the derivative of the bracket is minus 2, and then 4 over minus 2 equals minus 2. Okay, so copy those down if you didn't get them, and let's move on to the next page. I think there's one more page. And there's not one more page. So that's it. Basically, you can have easy ones like linear functions, or you could have complicated ones, but you're just looking for a multiple of the derivative. Okay, and there'll either be a worksheet or bookwork to do with this. Okay, that's it. Bye.